Hello everyone. So after like what 10-11 videos we are ready to move on to integration with partial fraction decomposition. Okay, all right, so I promise you it's going to be an easy ride from here, at least for 3-4 videos. Okay, anyway, now I'm going to teach you integration in the same way that I taught you partial fraction decomposition. We are going to touch case 1, its sub cases, and then we will move on to case 2. Okay, alright, so we have to integrate this rational function. So why do we need partial fraction decomposition? The reason is that this fraction is too complicated to integrate. So what we are going to do is we are going to do partial fraction decomposition separately to that rational function, and instead of integrating this fraction, okay, this rational function, we are going to integrate the decomposition, because decomposition contains easier rational functions or easier fractions to integrate rather than what we have, okay, what we are given, what is given to us. Okay, all right, so we start with partial fraction decomposition. So what do we do here? This is case 1 because numerator is smaller than denominator, so we factor the denominator as much as possible. So if you factor this, I will quickly say you're going to get x minus 2 and x plus 1. So the decomposition is a over x minus 2 plus b over x plus 1. Alright, so now we multiply both left hand side and right hand side by this big denominator. So on the left hand side we have 5x minus 4. Okay, on the right hand side we will get a times x plus 1, b times x minus 2. We already saw this right in previous videos. Alright, so let's choose the magic number x is equal to 2. So when x is equal to 2, 5 times 2 is 10, 10 minus 4 is 6, 2 plus 1 is 3. So a is going to be nice, a is 2. Now if you use the magic number x is equal to negative 1, negative 1 times 5 is negative 5, negative 5 minus 4 is negative 9, negative 1 minus 2 is negative 3. Oh nice, b is what? Guess what? It's 3. Not a, b. Alright, so what is the decomposition? Well, the decomposition is, so this is the fraction 5x minus 4, x square minus x minus 2, and a is 2, 2 over x minus 2, plus b is 3, x plus 1. See, now see for yourself. What we have here is much simpler than what we got. Okay? Alright, so now let's do integration, because what you have to do is you have to integrate. So you have to integrate the left hand side, but it's same as integrating the right hand side because of the equal sign, right? So let's focus on the right hand side. Now here we have addition, so we can integrate each fraction separately. Alright, so we can split the integration because of that addition operation. Okay, here. Now think about this. What is the integral of 2 over x minus 2? Well, we can take that constant outside the integral. So let's do that also. Let me do this very slowly. So we can take 3 also out of the integral. Now what is the integral of this part? So I guess we need a quick review, right? I did this in my basic integration review series. So what is the integral of x1 over x plus a? There's a formula. It's natural log absolute value of x plus a. Okay, so based on that, this is going to be 2 natural log x minus 2 plus here 3 times natural log absolute value of x plus 1 plus arbitrary constant of integration. See, once you do the decomposition, it's easy. So what I did here is I solved case 1, distinct linear factor case. Alright. Okay, now I want to show you very important thing. One thing that you can get, one thing that you can do mistakes. I have seen lots of students do this mistake. So let me take a different example. So the example is question number 2 is you have to integrate x plus 2 over 2x plus 1 x minus 1. Now, once you do the partial fraction decomposition, this is what you get. I'm going to give this to you, okay? I'm not going to do the partial fraction decomposition here. You already know how to do that. So the decomposition is 1 over x minus 1 minus 1 over 2x plus 1. So let's integrate. So you want to integrate with respect to x. Okay, So we can integrate the decomposition. Instead of integrating this, we can integrate the decomposition. All right. So how about the first fraction? So let me write it nicely. All right, minus integral of 1 over 2x plus 1. So here's something that you should add to your notes. Integral of 1 over x plus 1, super easy. It's natural log absolute value of x minus 1. Sorry, not x plus 1. Okay. All right. Here minus. Now what is the integral of 1 over 2x plus 1? Well, natural log 2x plus 1, right? And plus c. Well, you're almost correct. So there's a one mistake that you do. You forget about this too. Remember, in all the examples that I did, I never had a coefficient in front of x, even in the previous case. Okay, there was no coefficient in front of x. So what's going on? What should we do with these two? Do you remember the formula? So if you have an integral, if you have a function to integrate like ax plus b, the integral is natural log absolute value of ax plus b. But the difference is you divide by a, not multiply by a, divide by a. So don't forget that a. So divide by 2. Just that term. So that's the integral. So don't forget that. It's a common mistake. Okay. All right. One more problem. I'll give the decomposition and just to make sure that you understand the integration. So we have to integrate x plus 3 over 2x plus 1. Same case, but I change few numbers here. I change the number here. So the decomposition here is you do the partial fraction decomposition first. You can do it by yourself. Okay, try to do it by yourself. I will give you the answer. Okay, I will focus on the integration. All right, now you want to integrate, right? So you want to integrate, you know the decomposition, you can do the integration separately. Okay, so here now you have 3 and 4, two constants in numerator and denominator. Well, you can pull them out. So 4 over 3 integral of 1 over x minus 1 dx. Here you can pull 5 over 3 out of the integral. But you cannot pull that 2, okay? You can, but you have to do a little bit of work if you are pulling that out. Alright? But leave it be there and remember that rule. Okay? So I'll show you the other option too. But this 2 is only bonded with 2. X, I'm sorry. This 2 here is only bonded with x. This 2 does not belong to 1. So you cannot just simply take that 2 outside the integral. Okay, but you have to do it carefully if you are going to do that. But this 3 is bonded with the whole expression. So I can take that 3 outside the integral. Okay, so that's the difference between 3 and 2 there. Role of 2 and 3 there. Okay, so if you integrate here, 4 over 3 stays there. Natural log absolute value of x minus 1 minus 5 over 3 natural log of 2x plus 1. And because of these 2, you divide by 2. Okay, so 3 times 2 altogether it's going to be 6. So be careful, plus c. Okay, does that make sense? So be careful with the integration there. All right, so let me go back. Now, how about if you want to take that 2? So let me do it as a separate example. How about if you want to take that 2 out? You don't like it there. What should you do? So if you want to pull that 2 out, well, pull it out. So you have half 1 over here x plus divide 1 by 2. Okay, because you are pulling 2 out means you are taking out 2 out of the whole expression. So it's going to be 2 times x plus half. So x plus half should be left here. Okay, now you can do the integration. So it's going to be half natural log x plus 1 half. Okay, so it's the same answer. Okay, doesn't matter what method you do it, it turns out to be correct. Okay, all right, so that's what I have for this video. So in this video we learn how to integrate a rational function when it contains distinct linear factors. Okay, now in the next video we will learn we have a rational function where we have repeated factors, and then how do we do the integration. Okay, because we have to be careful. Okay, there are different integrating strategies. Okay, all right, thank you very much. Bye bye.